So in the last video, I showed you how to create this CSV so that we can plot our precipitation and temperature data for the coordinates that we've extracted through Google Earth. But the problem is I want to visualize each point from the grid cell from which it comes from. And having these references with numbers down the side is not going to allow us to do that. So I reformatted and created another CSV that replaces each degree grid square with a number. It's important to note that I have another Excel worksheet with these numbers matching the place names as in the last sheet, so that I can always go back and track which climate data belongs to what exact location. So we will have to use this to calculate our convex hull and the area of that convex hull. But we'll have to use a different CSV to plot the graph with a discrete scale. And I'll show you what that means now. So we go back into our R script and make sure our working directory is set and that our packages are loaded. And here in the middle of the code where it says plot climate data to identify extreme points, you see you have to load the package tidyverse, install it if you don't have it. And then we're going to bring in our climate data world with the grid references as groups of numbers. And we don't have to specify a row name here. What we do have to do is specify that grid, which is our reference for which grid cell the data comes from. We have to specify that that's a factor. And so what we are going to do is create a polygon or convex hull, which is a geometric shape that is optimized to fit around your data. And it shows you the area that your data covers. So this will show you the variation in climatic data of precipitation and temperature across all of the coordinates that we have extracted. To do this, we're going to use the Tibble function and the convex hull function found in tidyverse. And if you extract your own data, you have to look at this line of code and see how many observations you have and replace these numbers with the amount of observations you have. So we run this. Here we are going to create a convex hull using the climate data object we've just created, using the variables of average precipitation and average temperature. We can plot this to see what the convex hull looks like using grid as our color scheme, but because our grid references are numbers, R has been reading it in as a scale, which it didn't do for me before, but exciting piece of software this is. It sometimes has a mind of its own. So in order to calculate the area, we have to use this one Excel spreadsheet or this one CSV and then use a different one to plot the graph. Firstly, load the library Splanks or install it, and then run this line of code which will calculate the area of this convex hull. And here we go, that's the area of the convex hull, showing how widely spread our data is essentially, or what extent our data covers, which shows that the climatic data from these extreme points of the Earth covers quite a large area on this graph and this graphical space. Compare this to the area that I got for calculating the climatic data extracted from all the way across South Africa at 0.5 degree squares, which was only 59. So South Africa's climatic environment is not as expansive as these other areas of the earth. So now the issue I couldn't get around by using the same CSV is calculating this area at the same, and then being able to use it to plot this graph, but with a discrete scale. So if anyone has some advice for me there, please help me out and let me know. But just for the sake of this video, I created that separate CSV saying plot climate data world, which you'll have to bring in now. And you can see it uses the names of each grid cell as a character instead of a number. I'm still not sure how that problem happened in R, because the script ran, it worked once, and then the next time I ran it, it worked differently. So if we bring that in, classify the grid as a factor again, run the convex hull with this data set, plot climate data world, we should get a discrete scale with the names of our places. I should really put them in capitals. I'm going to do that. But that is all I have for you to show you how to apply convex hull to your data, and I hope this has helped. Please contact me if you get stuck on something, or if you have improvements for me, and that is a very contextual if. I mean, when you have improvements for me. Yeah. Thank you everybody for watching.